Good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. As many of us know, next week is World Ocean Week, and we're excited to be collaborating with ECOP Canada and the Canadian Ocean Literacy Coalition to bring the adventures and stories of early career ocean professionals from different disciplines to youth around the world. For those who don't know, ECOP does stand for Early Career Ocean Professionals. They are a global collaborative network that is focused on uplifting the diverse perspectives of new generations of ocean professionals through a collective voice, ensuring that knowledge is transferred between experienced professionals and the next generations to promote ocean sustainability for the ocean we want. This program is endorsed by and part of the UN Ocean Decade for Sustainable Development. And so for today's event, we are being joined by Brittnie Spriel. She is a research technician at the Juanes Lab at the University of Victoria, where she will be starting her master's on the bioacoustics of kelp forests in September. She's also the project coordinator of a new educational program called FishSounds Educate, which aims to promote public ocean literacy. So in her role, she develops and delivers outreach content and loves being able to make marine science accessible and relatable to learners of all ages. So let's bring Brittnie in live with us right now. Here we go. Hey, Brittnie, how you doing today?
I'm great. How are you?
Good, Brittnie. Great. We have an awesome group of classrooms joining us from across Canada and the US today. We've got them hanging out in camera spots. We have them hanging out via YouTube. So if you are on YouTube, send us a message, say hey, send some questions in the chat when it comes. We're going to play some Kahoot. Brittnie, it's going to be a busy event today.
Amazing. I'm so excited.
All right. Well, Brittnie, I'm going to let you take over for a little bit, and then, we'll go from there.
Sounds good. All right. Oh, and it's shared. Okay, we're all good to go. All right. Hello, everyone. I wanted to start off by acknowledging that I am speaking to you all from the Bamfield Marine Science Centre on Vancouver Island in Canada. And we are located on the traditional territory of the Huu-ay First Nations. And I feel very lucky to be able to learn and live on land that has been taken care of since time immemorial. My name is Brittnie Spriel, and my pronouns are she, her. And I thought I would start by telling you all a little bit about my interests. I love doing as much as possible outside, including climbing, as well as hiking and camping with my friends, and occasionally falling off surfboards. Bonus if any of these activities are happening near the ocean. But these days, I spend most of my time talking to students like you about a very fun topic, and that's fish sounds. But before we get into fish sounds, I just wanted to let you know a bit more about my education. So around springtime last year, I graduated from the University of Victoria with a Bachelor's of Science, concentrating in marine biology. So in my final year, I did an honors project on the effects of temperature on kelp in Brittnie Sound, which is in Bamfield, where I am now. So this is how I learned a lot about the ecology of seaweed and really fell in love with kelp. So then starting last summer, I became a research technician in the Juanes Lab at the University of Victoria, where I mostly stayed in the lab dissecting salmon stomachs to identify the different types of prey that salmon eat. So in this very happy picture of me, I'm holding a white bucket, but inside that bucket is a bunch of fish guts. So sometimes you really got to get your hands dirty when you're doing marine biology. So I'm still a research technician in the Juanes Lab, but my role has changed. So instead of dissecting stomachs, I have been the project coordinator of a new program called FishSounds Educate. So in this role, I make educational content and deliver it to students of all levels of learning, from kindergarten to university to lifelong learners. And I wanted to share some of that super cool information today, if that's okay. So let's just start by talking about why fish communicate. And there's three main reasons. The first one is to mate, to attract mates. And the second one would be to warn other species away from their territory or from their own food. And the last major one is to make distress signals. So an example of this would be our striped cusk eel here in the picture. And I'll play you a sound that the striped cusk eel makes to mate with other fish. Pretty cool, right? So sound is actually better than sight or smell, even though fish do use sight and smell to communicate. And one of the reasons is because it's really hard to see in dark water, and majority of the ocean is quite dark. Whereas sound can travel, and it doesn't matter whether it's light or dark. It's also hard to smell fish far away, so some fish do use chemical cues to interact, but these chemical cues can't travel very far. But sound travels super fast and super far in water. And I wanted to know what you think. How many soccer field lengths do you think sound travels in 1 second in seawater? And I'll give you a hint that in air, sound can travel the length of 3 soccer fields in 1 second. So remember that sound travels really fast in water.
All right. As promised, classrooms, we're going to put a few of you on the spot. So how many soccer fields do you think sound travels in 1 second in seawater? Let's start off with Mr. Hancock's crew. Do you have a guess over there, Mr. Hancock? Oh, your sound's not coming through, Mr. Hancock. 5.
5. Okay.
Perfect. All right, we got that. Let's try Miss Edie's crew. What do you think, Miss Edie's crew?
What do you guys think?
30.
30.
Wow.
6. There's a couple guesses. Let's do one more class. Miss Melnick's class, what do you think? How many soccer fields?
16.
16. 1.
16.
Right.
Okay, those are some awesome guesses. I would say whoever guessed 16 was the closest. It's actually 15 soccer fields in 1 second, compared to only 3 soccer fields in 1 second in air. So sound travels 5 times faster in seawater than in air. And that has to do with something called density. So all the particles are much closer together in seawater. So it's almost like having dominoes that are stacked much closer. They're all going to fall much faster. So fish really use this to their advantage. And even whales are able to communicate ocean basins away because of the properties of water, which is awesome. Okay, I have another question for you. I want to know what you think non-living sounds fish might hear in the ocean. So, for example, a non-living thing could be a chair or a rock.
All right, let's grab a few groups here, see what they think. There we go. Mrs. Thorpe's crew, what do you think? Any guesses for a non-living sound a fish might hear? You can type it in the chat too, if you don't want to unmute. Same for Mrs. Evans' crew. Mrs. Evans, does your crew have a guess for a non-living sound?
Yeah, they said boats or ships.
Boats
For
or
sure,
ships?
yeah.
Yeah. Let's try another class here. What do you think, Miss Melnick's crew?
We were looking at like sand moving in the waves.
Yeah,
Okay.
awesome. Waves.
Good one. Excellent. All right, there's some good answers.
Yeah, those are some great guesses. So I'll add to those by telling you that fish are able to hear things like earthquakes and tectonic plates, wind and storm, which will cause waves to crash on the surface of the ocean, waterfalls if they're in a freshwater ecosystem, reef sounds, so the water flowing through reefs will also make bubbles and sounds. And another example is precipitation, so things like rain and hail. Okay, so another question I have for you is what living sounds you think fish can hear? So what things that are alive in the ocean do you think fish can hear?
All right, so send those answers in the chat. I'll read a few of those out, but let's grab a couple different groups this time. Miss Edie, what do you think? What are some sounds?
Other fish.
Fish?
Other fish and eels.
Eels. Okay, cool.
Sharks.
Sharks. Okay.
Sure.
Let's grab another camera class, or let's try Miss Evans. Miss Evans, what do you think? Any guesses on your end?
I've got dolphins, electric eels, and octopus.
Okay. And then let me check the
Amazing.
chat. I see a couple in the chat here. Seaweed moving in the current. Miss Thorpe's group thinks plants. So there's a few good guesses.
Yeah, I love the creativity. Those are awesome guesses. And I'll add on to those. So fish can hear other fish feeding. So for example, this parrotfish is actually quite loud when it crunches on coral. Another example is whales. So somebody mentioned dolphins, also whales when they're breaching and slapping their tails on the surface. Somebody said other fish, which is absolutely correct. They can hear other fish talking to each other of the same species and other fish of different species. And then we have marine mammal echolocation. So that's when marine mammals send off a ping and it bounces off of their prey, and then they're able to detect where their prey are and build sort of a mind map in their minds. And then just swimming of other creatures in the ocean. And our last example is invertebrate communication. So for example, snapping shrimp, their snaps are quite loud. Okay, awesome. So all of these sounds that we've brainstormed and that I shared, they all make up something called the marine soundscape. And that's basically an amalgamation of all of the sounds that we can hear in the ocean. So we talked a bit about how fish use sound to communicate with each other. But there's multiple ways that they use organs in their bodies to produce these sounds. So one of the ways is through vibrations of muscles on their swim bladder. And their swim bladder is this gas-filled organ inside the fish. And I have an example of what that would sound like. So this is a midshipman vibrating muscles on its swim bladder so fast, they are the fastest moving muscles of all vertebrates. Pretty cool, right? It sounds kind of like a foghorn. It doesn't even sound like a fish, but it really is just a fish using its swim bladder to make that sound. So the other main way that they produce sounds is through something called stridulation, and that's when they actually rub their bones together. So the example that we have here is a catfish using its pectoral fins to stridulate. Sounds kind of funny too. So fish make many different sounds, and there is a place where you can go to listen to all sorts of sounds from different fish species, and that's FishSounds.net. We actually have over 1,010 confirmed soniferous or sound-producing species on this website. So feel free to go there if you have time later. So I actually wanted to play a quick game with you called Guess That Sound. And all you need to know is that scientists have taken these sounds and categorized them based on what they sound like in real life. So knock, tick, jackhammer, these are all real examples of sounds that scientists have categorized. So I wanted to play a sound and then get you to guess whether you think it is A, B, or C. So I'll play it first. Okay.
Okay, let's put some classes on the spot. Let's start with Mr. Hancock's crew. See if they've got the mic going.
I think, can you hear us now?
Yeah, we got ya.
Perfect. All right, what do we think, everybody? Jackhammer. We're thinking jackhammer.
Jackhammer, interesting, okay.
Let's take one more class for this one. Let's go to Miss Melnick's crew, see what they're thinking.
We're thinking a tick, B.
Tick, all right.
Okay.
All right, Brittnie.
So the answer is jackhammer. So good job to the first class. Okay, next one. Maybe I'll play that one again because it was pretty.
Okay, grunt, croak, or boop. Let's see. Miss Edie's crew, what do you think?
Crow!
B. Got some croak, okay. Miss Evans' crew, what do you think?
Our majority is A, grunt.
Grunt,
Okay.
and let's see if we've got any in the chat here. We've got some coming in for B. Miss Thorpe's group thinks croak. Miss Edie thinks croak. Okay.
All right. So I think majority of you were right. That is a croak sound from a Lusitanian toadfish. And I love that it's a toadfish that makes a croaking sound. Okay, So that was our Guess That Sound game. And some of you may have noticed, like many other students, that some of these fish sounds kind of sound like farts. So we developed a game called Fish or Fart. And all you need to do is guess whether that is a fish sound or a fart sound that I downloaded from the internet. Are you ready? Okay, so here is the first because it's pretty quick.
All right, this is the perfect game for this age group. Let's
That's
what
kind of what we were thinking.
and see what they think. Miss Malnick, what do you think? Fish or fart?
We're kind of 50-50. We're thinking some of it's saying
50-50.
fart, some of them saying fish.
Okay.
All right, Mrs.
Okay.
Thorpe's group has gone all in on fart. Miss Edie's group is all in on fart. What do you think, Mr. Hancock?
We went fart as well, for sure.
Okay. All right.
Right.
Well, I hate to inform you, that was a fish. That was a juvenile meager making a distress sound.
All right, Mrs. Sterling's group as well. They fired in fart too, so you had
Okay.
you had them
I
fooled.
fooled you all. Okay, last one, I think, for this game. A little wet one.
Okay, let's get some classrooms in here and get their thoughts. Miss Edie's group, what do you think? Fish. Sterling Public School thinks fish. Miss Melnick's class,
What do we think?
they sound split again. Mr.
I
Hancock,
hear
what's the
split,
crew
yeah.
saying?
We're going fish on this one.
Going fish.
Okay. All right. Okay. Well, I think you were all technically right because that was a fish and a fart sound. That was a Pacific herring actually releasing gas through its butt. And that is how they communicate with each other. And they don't just do it by accident. They do it on purpose to maintain cohesion or togetherness when they're in schools. So you were all right. Scientists call this a fast repetitive tick. The acronym for that is FRT. So it kind of looks like the word fart. Scientists sometimes can be funny, or at least they can try to be. All right, so we have all of these incredible sounds that I've been playing for you, but how are scientists able to hear them? Does anyone have any guesses how we hear these sounds and record them?
All right, so let's get some classrooms here. You can type an answer in. Mrs. Evans, what do you think? How do we hear sounds underwater?
We're having some issues with our Zoom right now, so we'll get back to you.
Okay, let me know if you need the YouTube link as well today.
Okay.
Let's see. Mr. Hancock's crew, how are we hearing things underwater?
We're thinking there's something to do with some echolocation.
Okay. Miss Edie's group sent something in the chat. They think there's an underwater microphone.
Yeah.
Okay.
I'm going to tell you that's right on the money. So it is something called a hydrophone, which is a waterproof microphone. And that's actually what I'm going to be deploying later today. So these work just like a regular microphone does, but it has a waterproof casing so it doesn't get ruined. And these hydrophones work by picking up sound pressure at the microphone end and transferring it into electrical energy. And then we can actually visualize these sounds in graphs called a spectrogram. So for my master's starting in the fall, I will be deploying these hydrophones and listening to kelp forest soundscapes. And I want to know whether healthy kelp forests sound different than unhealthy kelp forests. And my idea or my hypothesis is that healthy kelp forests will probably be louder, and there will probably be distinct species that we can attribute to these healthy kelp forests. And that'll be really helpful in the future because we can just plop down these hydrophones and we can sort of tell sort of a general proxy of what the biomass and species would be like in a healthy kelp forest. So taking a look at these spectrograms again, it is basically a graph of frequency of sound waves over time. And we actually hear frequency seen on the y-axis as changes in pitch. So when the frequency is high, then the pitch is really high. And when the frequency is low, then the pitch is really low. So I wanted to play a sound and get you to think about how that sound matches this spectrogram here. All right. So we actually have one more guessing game. Now that I've let you know what spectrograms look like and how they work, I wanted to play a sound and get you to guess which of these 3 spectrograms is the correct one for the sound. So I'm going to play the sound now. Okay.
All right. Let's see. You can send in some guesses via the chat. Miss Thorpe's group thinks it's A.
A.
Miss Edie. I've got C. I've got A from Miss Sterling. Mr. Hancock's group is hedging their bets on A or C. All right.
Okay. So the answer
A or
is.
C.
So the answer is A. That was a haddock making a sound there. And if we take a look at the frequency, we can see it's super low. It's below 1, and that was a really low sound, right? So that kind of makes sense there. Okay, I have another graph here, but I've already told you what it is. But this is something that a lot of scientists are looking into. So we have 3 sort of fish sounds to start. And then this very huge sound at the end is actually boat noise. So as we can see, it takes a very long time because boats are in the water pretty consistently. And it's also very loud, and we can tell the volume based on how green it is. And the last thing we can tell is that the frequency that it covers is very wide. It's a very wide range of frequencies. So what you may not have been able to notice is that we actually played those 3 fish sounds again, but they're much harder to see on the spectrogram. And if it's harder for us to see them on the spectrogram, then that means it's a lot harder for us to hear the fish. And it also means it's harder for fish to hear each other. So boat noise is just one of the many types of sounds that humans make in the ocean. And I'll give you some other examples. So coastal construction, if there's construction on the coast, fish are able to hear that. Ships, as we just talked about, the boat there, but then also large cargo ships. Airplanes, they're low flying, and traffic that's along the coastline. There's seismic surveys when they send a very large blast so that they can tell what kinds of minerals are in the seafloor. And another example is resource extraction, for example, this oil rig here. So there are many ways that we can try and help the fish. One of them is by avoiding using these cargo ships, so shopping more locally, so we're not relying on all of this international shipping. We can do more research on fish and see what types of fish actually use sound to communicate, and then we can avoid using our boats in those areas. Now, I believe we have a bunch of time for questions. Thank you so much for listening and for participating. I loved all of your answers, and I'm really excited to see what you want to know about fish sounds.
All right. Well, Brittnie, that was a great presentation, great interaction for the classrooms, and definitely learned a lot about the cool sounds that fish are making. And then, of course, the impact we're having through the sounds we're making. Before we get into some Q&A action, if you are tuning in via YouTube, you can start putting some questions in via the chat. We're going to play a little Kahoot together. We're going to test our knowledge and see how well we do. So I'm going to share the PIN number here. It's kahoot.it when you go to the website, and then it's going to ask you for a PIN. It's 588894 today. So there it is. I can see we've already got lots of classrooms joining. So let me share my screen and I will bring up the Kahoot page, and you can see where to join there as well. There we go. So if you have one-to-one technology at your seat, well, you can join right there. If not, your teacher could put it up at the front of the room. You could shout out your answer to him or her. If you're at home joining virtually, you could use a phone or a tablet and scan that QR code, and it'll take you right in. There are 4 questions today. We've got a mixture of true and false and multiple choice. 20 seconds for each question. If you get it right, you're getting some points. If you get it right and you do it really fast, you get even more points. If you get it wrong, even if it's the fastest it's ever been put in the history of Kahoot, we got nothing for you. So you got to get that right answer. You got to get it in there as quickly as you can. We've got our animal names like the Captain Hare and the Gentle Chicken and the Zany Horse. Let's see if we have any fish names coming in here today. Don't see any yet. We've got an aquatic lemur. Not really a fish, but it's aquatic at least.
I didn't know they had those.
The lovely goose. All right. Very cool. So I'm going to give maybe 30 seconds if anybody else is coming to join. I still see a few students trickling in, a few classrooms. And then we are going to get our Kahoot started because we want some good Q&A time coming up next. The bright urchin. You would definitely find those in the kelp forest. There we go. We've got a kelp forest creature. The wise crab. It's a good one too. Okay, let's get going. 4 questions, 20 seconds for each. Counting us down in 3, 2, 1. True or false? Fish can hear sounds underwater. Is that true or is that false? Let's get those answers in nice and quick. Let's see if we can beat the clock. True or false? Fish can hear sounds underwater. All right, we know that is absolutely true. Good job to get us started, crew. Let's take a look at our leaderboard. The smart deer is holding down that top spot. But let's see what happens in our next question, a multiple choice. What do you call the collection of different sounds that can be heard underwater? Is it a sound ecosystem, an audio habitat, a soundscape, or a noisescape? So what is the collection of sounds we hear underwater? A sound ecosystem, an audio habitat, a soundscape, or a noisescape? All right, a bit more of a split, but most students went with soundscape. Let's take a look at our leaderboard. Lots of movement, but the smart deer is not giving up that top spot yet. True and false. Sometimes it's hard for fish to hear each other when boats are driving by. So true or false? It's hard for fish to hear each other when a boat is driving by. All right, that is true. Just like if we're on land and a motorcycle goes right by us while you're talking to your friend, it gets kind of hard to hear what's going on. Ooh, the great hawk has taken that top spot. We've got one more question to settle things. Multiple choice. Scientists can listen underwater using a waterphone, hydrophone, microphone, or a telephone. What are scientists using to spy on those fish? A waterphone, a hydrophone, a microphone, or a telephone? All right, good job, crew. It is a hydrophone. Let's look at our podium. In third place, we have the caring deer. Second place, the purple fox. And holding down that coveted top spot, we have the great hawk, held on for the last 2 questions. All right. I'm going to come back from that screen share. That was a great round of Kahoot. Let us jump into some Q&A with Brittnie. If you are in the YouTube chat, don't forget to use that and send us in some questions as well. And I can see in the private chat here that Miss Melnick's grade 5-6s are celebrating. Looks like they swept the leaderboard. So good job to our 5-6s from Nova Scotia. All right, let's bring in some classrooms here for some live Q&A action. We are going to start with, whoops, there's my page. We are going to start with, let's go to Mr. Hancock's crew, some 4th and 5th graders in Georgetown, Ontario. Here they come. Hey, Mr. Hancock, how's it going?
Good. You answered most of our questions already, but we're curious about how do you figure out where to put the microphone? And are you able to separate the sounds if boats do go by? And can you pull the fish sounds out from that?
Yeah, those are fantastic questions and things that I am thinking about right now as I'm doing my field work. It really depends on how long you want the hydrophone out there. Sometimes you can just have it hanging off a boat. If you are only there for a couple of hours, you can turn off the engine and anchor. For me, I've built stands that I will be deploying, and I'll be basically placing them just outside of the kelp forest and putting sandbags around them so that they're nice and secure for a couple of weeks. What was the other question about?
Are you able to pull out the sounds? Like if boats are going by all the time, can you separate the fish noises and such?
Yeah, so there is actually a software that we use called Raven Pro, and it's very fancy, and we can't pull them out, but we can basically crop out the boat noise. So I will be manually listening to all of the recordings and looking at them, and I can tell what a boat noise basically looks like, and I'll have to cut that out of the recording so that when we do the analysis, it doesn't include it.
Perfect, thanks.
All right, great questions. Okay, let us go to another classroom. This time we are going to, I want to give a shout out to Miss Jones' crew from Sterling Public in Ontario. It doesn't look like the devices are connected today, but if you use the chat sidebar and send us in a couple questions, I will read those out for you. But let us go now to Miss Melnick's crew, grade 5-6s, Nova Scotia, are celebrating class, having their big victory in the Kahoot. There they are. How are we doing, 5-6s?
We're doing good. We have Jamie here who has a question.
Okay.
Hi, Jamie.
Jamie's curious about how long salmon live.
Oh, that's a very good question. I guess it depends on the species, but I'm pretty sure it takes them a year. I actually don't know that much about salmon, but I'm pretty sure their life cycle is about a year.
All right. Do you have another question there, Miss Melnick's crew? Is there someone standing by?
We have lots of questions, but I don't know if you want to go to another group or not. It's up to you.
No, let's grab another one while we're here.
All right, we got Alex is up next.
How many sounds can one fish make?
How many sounds?
Yep. Yeah. So how many sounds can one fish make?
Oh, can one fish make? They can make many sounds. They don't just make one sound, so they kind of have like a repertoire. So probably from like 1 to 5, really depends on the fish. But yeah.
All right. Great questions. We'll see if we can swing back your way to snag a couple more. I'm curious. There's birds are really good at sounds, and they're really good at imitating sounds as well, some species. Is there any evidence of fish that can imitate sounds?
Oh, I have no idea. That's a really good question.
All right. There's a good little homework for our classes to see if there's any imitator fish out there who maybe can imitate some of the sounds that they hear. Okay, let's go to another live classroom. We're going to go to Miss Edie's 5th graders this time. Let's see if we can get them in front and center. Hey, Global Explorers, how we doing?
Good. We're wondering more to know about some ways that human-made sounds impact specific species of fish.
Yeah, that's a really good question. There's lots of ways. It can start all the way at the beginning of their development. So when they're in their larval stage in their eggs, it can affect their development, and maybe they won't be able to hatch if the sounds are sort of chronic and continuous. If the sounds are very loud, that would be an acute sound. It can really hurt them. So when I was talking about seismic surveys or construction, if it's super loud, it can even burst their swim bladder and they could die. But then there's sort of the chronic sounds that can interfere with the way that they communicate, and we call that masking. So it's almost like if you're in a really busy restaurant and you're trying to talk to your friend and it's so loud that you can't hear them. That kind of thing happens to fish, and it's harder for them to mate, and it's harder for them to defend their territory and just do their job as fish. Very good question.
Yeah, great question. All right, we'll swing back your way shortly. I want to grab a couple from the chat here. So our crew in Sterling are interested in the weirdest fish sound that you know of.
The weirdest fish sound.
Yeah.
Oh man, I don't know. I think the midshipman sound is pretty weird. The fact that it sounds kind of like a foghorn. There's also a fish called a drum that makes a sound called a pulse, and it sounds just like a heartbeat, which is pretty neat.
All right, very cool. Miss Evans' crew is tuning in with us, and I know they're having a little trouble with their connection. But they've got a good question here in the chat. They're wondering, sound. Is there a difference in the amount of sound that you would hear in cold water versus warm water? And then they're also wondering, same sort of thing, does sound travel differently in cold water versus warm water?
Yeah, so I would say it travels fast, or a little bit faster in warmer water than in colder water. And that's something that we have to sort of consider when we're conducting these sorts of research in temperate versus tropical waters. Yeah.
All right. And then maybe the second part to that was the amount of sound in cold versus warm. I imagine it would be more in warm water because there's just more life, more fish.
Oh, I see. Like, is there, like, ecologically?
Mm-hmm.
Well, it really depends. Majority of our studies have been in more tropical regions. So that's maybe why we actually have a lot more confirmed sound producing fish in those areas. But it is true, if we have a biodiversity hotspot like a kelp forest, then there is, or like a coral reef, then yeah, it is going to be a lot louder. For sure.
All right. Then we have Mrs. Thorpe's crew backstage. If you want to unmute your mic, or you can put in a question or two in the chat, and we will read those questions out for you, whatever you feel like doing. And then we're going to swing through, and we're going to take a couple more questions from some more of our camera classes, because we are almost out of time for today's event. And then no doubt all the students are going to go and take some time to play Fish or Fart after today's event, I'm sure. Okay, let's bring in Miss Melnick's crew, because I know they have a few questions hanging out for us.
Do fish get thirsty?
Oh, I think Brittnie might have froze for a second on us. Let's see if she comes back to us. We're having a good connection. Maybe while Brittnie is coming back, we'll see if oh yeah, she's reloading. Let's see. Okay, she might have to exit and come back in. So while we're waiting to see what happens, I want to share a few links with you. If you want to learn more about Ocean Week in Canada, oceanweekcan.ca is a great spot to go to learn a little bit more. And then another option here, we have more ECOP events coming up this week. exploringbytheseat.com/ECOP. You can find we have 2 more events coming up this week. One tomorrow about crossing the ocean, and then another on Friday. Oh, I think I hear Brittnie coming back in. And this one's more about saving and protecting our oceans. So let's see if that's Brittnie back there. Hey, Brittnie, how are you?
Hi. Good. Sorry, I don't know what happened with the internet.
That's okay. The internet doesn't always cooperate, but we
like
got you back.
I said, I'm in a more remote location, so I was worried that was going to happen.
That's okay. We hear you now. We see you again. Miss Melnick's class was just wondering if fish get thirsty. Did you get that question, Brittnie? Miss Melnick's class was wondering if fish get thirsty.
Interesting. No, I don't think they there must be a delay.
Yeah.
But no, because they have osmoregulation, they've got everything they need to, yeah, they don't need to drink water. They don't get thirsty. But that's a good question. Yeah.
All right, let's grab one more from Miss Melnick's crew. I think someone's come up to the camera.
What's your favorite fish?
That's a good question. I would say my favorite fish is called the mola mola. They're super weird looking fish. You have to look it up. But they're really huge and they can float along the surface of the water and they just look super funky. So that's my favorite fish.
All right, very cool. Our global explorers, do you have one more question for us before we sign off for today?
Do you study any other senses? Like, do you have something to use, like hydro cameras or anything? Like, or is it just hydrophones?
So I'm not using cameras, but a lot of scientists do because it helps us to identify who is making the sound. So that's a very good point. And that's something that a lot of scientists are doing. So yeah, good question.
All right. Thanks, Global Explorers. Brittnie, thank you so much for spending a little bit of time with us today. That was a really great presentation. The Kahoot was a lot of fun. We had great questions from our classes. And it sounds like when you're done with us today, you're heading out into the field.
I am. Yep. I'll be off on the boat today.
All right. Very cool. Well, classrooms, thank you so much for being with us. Thank you for your amazing questions, as always. Before we sign off, we have a few classrooms had to duck out for recess. A few are in audio spots, but let's bring in a couple camera classrooms in case they want to get nice and loud and say a big goodbye and thank you before we sign off. There they go. All right. Thanks so much for hanging out with us. And a reminder, we've got 2 more ECOP events coming up tomorrow and then Friday. So again, visit the website that I shared earlier, exploringbytheseat.com/ECOP, and you can check out those events and register to come and hang out with us before World Ocean Week. Brittnie, have fun on the boat. Hope you hear some really cool sounds, and hopefully you can come back with some more fish games for us.
Sounds good. Thank you so much for having me. Thanks everyone for participating.
All right. Thanks everyone. We're going to sign off for today. See ya.